We are jumping straight into it today, analyzing the brand new Gemini 3 Pro model card. If you're an engineer or researcher, this is for you. We're going to pull out the high-impact essential facts you need to know about Google's new flagship model.
And the headline here really isn't just an incremental update. This is a pretty decisive architectural leap, I think, toward what you could call agentic AGI. The model card confirms it's a sparse mixture of experts, or MoE transformers.
Which is so critical.
It is, because it decouples that huge model capacity from the raw computational costs.
Right. And that capacity means real scale you can actually use. We're talking native multimodal text, audio, image, video, and just an enormous 1 million token context window, plus a 64K token output. That changes things for developers, like today.
And the performance numbers really back this up. We're looking at demonstrated PhD-level reasoning. You've got 91.9% on GPQ-8 Diamond and 37.5% on Humanity's last exam, and that's without any tools.
And for all the builders listening, this intelligence is immediately useful. It's agentic. It's topping the web dev arena, and this is the big one for me, it hits 76.2% on the SWE bench verified benchmark, which is just wild.
Finally, we have to mention the safety. This is the most comprehensive evaluation we've seen using the Frontier Safety Framework, the FSF, and it confirms that no critical capability levels, or CCLs, were reached. So that's the 1-minute summary.
Okay, let's unpack this properly, starting deep in the engine room with the foundational specs of Gemini 3 Pro. The card makes it very clear this is a next-generation model.
Yes, and they really stress that this is not a fine-tune of 2.5 Pro or any prior model. It's a completely new build from the ground up.
And that new foundation is all about this sparse mixture of experts architecture, the MoE model.
Right. And, the core idea has been around for a while. Shazir et al. Published on this back in 2017. But as always, having the theory and actually implementing it at this kind of massive scale are two very different things.
For anyone who's maybe familiar with MoE, can you give us a quick analogy for why that dynamic routing is so important, especially when you're dealing with a million tokens of context?
Absolutely. So think of a standard model as one giant brain. Every single question, every token lights up the whole thing. It's powerful, but incredibly inefficient.
Right.
And MoE model is more like a specialized consulting firm. When a token comes in, a router decides which small group of experts, which subset of parameters is best equipped to handle it. So if it's a math problem, it goes to the math experts. If it's code, it goes to the coding team.
So you're not activating every single parameter for every single thought, which is, I imagine, incredibly expensive and slow.
Precisely. You only light up a small fraction of the total parameters, and that lets you build a model with a truly massive total capacity. But the actual serving cost, the latency per token, stays manageable. That's the only way you can really make a 1 million token context window practical.
So what does that 1 million token window actually let you do? I mean, that number is so big, it's almost hard to get your head around.
It completely redefines what you can use as an input. I mean, we're talking about feeding it entire data sets, huge complex documents, long audio files, video, and this is the critical part for developers, entire code repository.
A whole repo.
The whole thing. You can give it the full documentation for a complex library and just ask it to write a patch or explain a dependency. That's a huge shift.
That ability to just ingest an entire repo without any pre-training or fine-tuning, that's a massive deal for enterprise use. So, okay, how do they feed this thing? Let's talk training data.
The card mentions a large-scale, diverse, and natively multimodal collection. So you have the usual suspects, public web data, license data, and some user data with, the standard controls.
But there was one thing that really jumped out at me, something that points to where frontier model training is going. They explicitly mention AI-generated synthetic data.
That's it. It basically confirms what many of us suspected. Synthetic data is now a critical piece of the puzzle. The model isn't just learning from what humans have written, it's learning from its own curated, self-generated examples.
Which is probably essential for teaching it things like multi-step reasoning and problem solving.
Exactly. The kind of skills you need for true agentic behavior. And the post-training, using reinforcement learning on stuff like theorem-proving data, just doubles down on that goal. It's all pointing towards agency.
And this was all done on Google's own hardware. Their TPUs, the tensor processing units, all orchestrated with JAX and ML pathways. It's a vertically integrated stack, which makes sense for this kind of scale.
So with that architecture in place, let's look at the results. Because what's fascinating here is that the scores aren't just a little better, they're They're a step change. It outperforms 2.5 Pro on basically every major benchmark.
Let's start with the general stuff. It tops the El Marino leaderboard, which is a big deal, with a score of 1501 ELO. But for our audience, I think the really interesting numbers are in those hard reasoning benchmarks.
I agree. The PhD level reasoning scores are, well, they're definitive proof that we're moving beyond simple pattern matching. Hitting 91.9% on GPQA Diamond, that's a set of really hard university level science questions, is one thing.
Yeah, that's impressive.
But for me, the 37.5% on humanities last exam, that's the one. These are questions designed to be almost impossible, testing really deep scientific synthesis. And it got that score without using any external tools. That shows real, complex problem solving.
And it's not just a one-trick pony for science. It also set a new state-of-the-art in math, 23.4% on Math Arena Apex, and has really strong factual accuracy at 72.1% on Simple QA Verified. It's just a very, very capable model across the board.
And it's capable in a truly multimodal way. This is where that million token context really starts to shine. It redefines multimodal reasoning with scores like 81% on MMU Pro and a huge 87.6% on Video MMMU. It's not just looking at inputs side by side, it's actually synthesizing them.
Can you give us a concrete example of that synthesis from the card, something that really makes it click?
Yeah, the internal examples are pretty striking. So imagine you ask it to analyze a really complex physics concept like the chaotic plasma flow inside a tokamak fusion reactor.
Okay, yeah.
The model can first understand the physics, then generate the actual high-fidelity code to visualize and plot that flow, and then write a poem that captures the metaphor of nuclear fusion.
Wow.
That ability to move between deep technical understanding, computational execution, and creative expression, that synthesis is the real leap here.
Okay, and this is where it gets really interesting for me. The Ultra tier, which they're calling Gemini 3 Deep Think. This is the enhanced reasoning mode that they're holding back a bit for more safety testing.
Yeah.
What do the numbers look like there?
Deep Think pushes everything even further. So humanities last exam jumps to 41.0%. GPQA Diamond goes up to 93.8%. But the number that will really get AGI researchers excited is the 45.1% it scored on ARC AGI2 using code execution.
For those who aren't familiar, what does that ARC AGI benchmark actually test? What does 45.1% mean?
ARC AGI is all about measuring generalized or liquid intelligence. It gives the model novel problems that require genuine insight to solve, not just recalling something from its training data. A score of 45.1% suggests a pretty remarkable ability to reason from first principles and solve problems it has never seen before. It speaks to, a potential for true AGI capabilities.
And the fact that they're keeping this tier restricted for now just underscores how powerful they think it is.
Exactly.
So this abstract intelligence is great, but how does it translate into tools for builders? This is where it gets really interesting for developers.
Right, and they're not shy about it. They're calling Gemini 3 the best vibe coding and agentic coding model. That term vibe coding, I find that fascinating.
Me too.
It's their attempt to describe its zero-shot ability. You can give it a really ambiguous, complex, or just, a vibe of what you want, and it can generate rich, interactive web UIs or complete code snippets from that. It feels more like an intuitive partner than just a tool.
And you see that in the hard metrics. Topping a Web Dev Arena leaderboard at 1487, ELO is great for UI stuff. But the number that made me sit up straight was its performance on SWE Bench Verified. It blows 2.5 Pro out of the water with 76.2%.
That 76.2% is a bombshell. SWE Bench tasks the model with fixing real bugs from open source GitHub repos. It has to analyze the issue, plan a fix, write the patch, and then validate it. A score that high suggests we're moving from coding assistant to a genuine autonomous software engineer that can handle complex maintenance tasks.
To do that kind of work, you need more than a prompt window. Which brings us to Google Anti-Gravity, their new agentic development platform. What is that exactly? How does it change things?
Anti-gravity is basically a dedicated workshop for the agent. Before, you'd prompt an LLM and get code back. Here, the agent lives in its own environment with direct access to an editor, a terminal, and a browser. The entire platform is designed to let the agent plan and execute complex end-to-end tasks on its own.
And critically validate its own work.
Critically, it can run tests, check the output, see if the UI looks right in the browser. It's a closed loop.
So I can tell it to, say, add a new payment provider to my app, and it will plan the steps, write the code, run the tests in the terminal, check the payment flow in a browser, and then commit the changes, all by itself.
That's the vision. And the long horizon planning benchmarks support this. It topped the Vending Bench 2 leaderboard, which tests decision-making over a long period. The card says the model maintained consistent tool use and decision-making over a full simulated year of operation. It didn't drift off task.
A full simulated year of consistency. That's a huge problem to solve. Previous models would often lose context or just wander off after a few dozen steps.
And that consistency is tied directly to that 1 million token context. Think about it. You could feed it a company's entire financial history, all the reports, videos of shareholder meetings, and then task it with a complex compliance workflow for months. It has the context and the consistency to actually do that now.
Okay, this brings us to the big critical question. A model this powerful. What about the frontier risks? How is Google handling safety?
They say it's their most secure model yet. They detail all the mitigations, dataset filtering, RLHF, critic feedback, all the standard stuff. But we need to look closely at the internal safety metrics they shared.
And there's one number that immediately jumps out. A regression. The automated evils showed a drop in text-to-text safety of minus 10.4% compared to 2.5 Pro. Now, wait a minute. Any regression in safety seems like a massive red flag, doesn't it?
It is, and that's the critical point for anyone looking at this data. The card addresses it directly. They claim that when they did a manual review, these flagged instances were overwhelmingly either false positives from the automated system or what they call non-egregious issues.
But non-egregious is a very subjective term. It almost sounds like the model got so much smarter that it's now outsmarting the automated safety tests.
That's a great way to put it. It signals a real challenge in safety scaling. As the models get more complex, our automated safety tools are struggling to keep up. That said, they did show improvements elsewhere. Tone was up nearly 8%, multilingual safety was up a little. The takeaway is that this new architecture is just different, and the old tools need to catch up.
Okay, so let's move from the internal metrics to the really crucial part, the Frontier Safety Framework analysis. The headline here is that the card states clearly that Gemini 3 Pro did not reach any critical capability levels, or CCLs.
That's the bottom line, yes. But let's dig into the details, starting with CBRN chemical, biological, radiological, and nuclear threats. The model hit uplift level 1, but the CCL was not reached. Meaning, while it can give you accurate textbook-level information, their testing showed it generally fails to provide novel or complete enough instructions to actually help a threat actor build something dangerous. The info is out there, but the model can't synthesize it into a truly hazardous new recipe.
Okay, what about cybersecurity? This feels like the most immediate risk, given how good it is at coding.
Cybersecurity is also uplift level 1, so the CCL was not reached. However, and this is a big however, the alert threshold was met.
What does that mean?
It means the model showed it has highly capable individual hacking skills. It solved 11 out of 12 of their V1 hard challenges. So it's very good at specific component-level hacking tasks, which triggered the alert.
But not the full CCL. Why not?
Because it failed to solve any of the 13 end-to-end V2 challenges. Those require planning, coordination, and long-term execution to pull off a full, complex cyber attack. So it has the skills, but it can't yet chain them together into a strategic autonomous weapon. Not yet.
And the last category, misalignment. This is where you test if the model starts pursuing its own goals.
Right, strategic autonomy. The agent solved 3 of 11 situational awareness challenges and only 1 of 4 stealth challenges. So it has some foundational planning abilities, but it's not demonstrating dangerous levels of self-motivated autonomy in these tests. It's an agent, but it's not a rogue agent.
So what does this all mean for developers today? The capabilities are obviously huge, and the safety analysis, while needing a critical eye, seems to clear it for general release.
It's rolling out now. Developers can get it in AI Studio, Vertex AI, the CLI, and through that new anti-gravity platform. The DeepThink Ultra tier will come later. The immediate impact is that the 1M context and that SWE bench score are going to massively accelerate building real, robust, autonomous agents.
So we've seen this decisive leap in reasoning, multimodality, and agentic coding, all built on a more efficient MoE architecture.
Yes, but the model card itself points to a key remaining limitation. It mentions possible degradation in multi-tier conversations, even with all the gains and long horizon planning. And that, for me, is the final frontier here.
Because the goal isn't just to solve one problem. The goal is an agent that can operate autonomously for weeks, months, fixing code, managing systems. For that, you need perfect multi-turn reliability over very long periods.
Exactly. We've seen it plan over a simulated year. But the hardest problem in AGI isn't just stopping a one-shot jailbreak. It's about mastering that continuous, multi-step, multi-turn reliability when an agent is running loose in a complex system for months on end.
How do you guarantee that its deep intelligence doesn't drift? That it doesn't forget some critical piece of context on turn number 5,000?
You've hit it. That's the open research question. That continuous reliability is what will separate today's powerful tools from tomorrow's truly autonomous agents. And that's the frontier to watch.
A perfect thought to leave our audience with as they start building with Gemini 3 Pro. Thank you for joining us to break down this model card.
My pleasure. Thanks for having me.